chemical mixture problems type A. This really just means we're going to do some other chemical mixture problems, and they're going to be a little bit tougher. So this is sort of a warm-up. I gave you guys the general setup. You guys are going to want to definitely put that in your notes. It's always V1 plus V2 equals VF, and C1 V1 plus C2 V2 equals CF VF. You could do 3 if you want. This just means final. So with these problems, we're mixing them together, and then you get a final one. Yeah. So V means volume, which you'll be able to tell from the problems. And C always means concentration, but you're going to want to write concentration of the stuff, or I like to say of the stuff. The reason why I put this is because sometimes they try and throw you guys off, and they'll put the concentration of the stuff, and they'll also put the concentration of the water. Whenever it says concentration of the water, we can just get rid of it. We don't care about it. We care about the stuff. So for this one, it's salt. Sometimes it's iodine. It's some sort of a solution, just like in chemistry class. I don't know if you guys take chemistry yet, but these are just different concentrations, and we want the stuff, not the water. Okay. The chemist has one solution that's 25% salt and 75% water, and another solution that's only 5% salt. How many milliliters of each should the chemist use to make 1,600 milliliters of solution that is 15% salt? So really all we need to do for these problems is go through, and we're going to label every little piece, the number piece, what it's going to end up being in our equation. So a chemist has one solution that's 25% salt. I want the salt percent. I'm going to make this my C1, my first concentration. And 75% water, this is where I'm saying that they might try and trick you guys. The 75% water we do not care about, so I'm just going to squiggle it out. And another solution that's only 5% salt. So here's another salt concentration. We're going to make that my second concentration, C2. How many milliliters of each should the chemist use to make 1,600 milliliters of a solution that's 15% salt? So what this guy's doing is he's mixing them both together to give us 1,600 milliliters. So this is our final volume. Our volumes are, I think, will always be in milliliters, maybe sometimes liters, of a solution that's 15% salt. So this is after we mixed it, meaning this is going to be our final concentration. So we've gone through, we've labeled everything, and now we can just plug it into our equations. So our first one is just our volume equation. The V1 and the V2 are what we're solving for, so we're just going to leave them as V1 and V2 when we write our equation. So V1 plus V2 equals VF, which we labeled in the word problem, 1,600. Our second equation is our one with the concentration, so we're multiplying the concentrations and the volumes together. Our C1 we labeled as 25 times V1 plus C2, which was 5, so 5 times V2 equals, this is where a lot of people get tripped up, you guys, we have to multiply together the final concentration and the final volume. So it's tempting to just put the final concentration, but we need to multiply it by our VF. So we're going to have 1,600 times 15. Multiply them together. Now we just have a system of equations, just like you guys have done for a million other different type of problems. You can solve these however you want. Usually they should lend themselves pretty well to substitution though. So if I wanted to subtract V2 from both sides, minus V2, I get that V1 equals 1,600 minus V2, and then I can just plug this in as a chunk for V1 in the other equation. So 25 times my new V1, which is 1,600, minus V2, and then I'm going to have plus 5V2 equals 1,600 times 15, which is 24,000. These ones are going to give us really big numbers. Now I have this 25, and then I have the parentheses. You have to make sure we distribute here, so the 25 has to be multiplied to both pieces. This gives me 40,000 minus 25V2 plus 5V2 equals 2,400, and then I just combine like terms and solve. So negative 25 plus 5 gives me negative 20 V2. I'm going to subtract over this 40,000. It's going to give me negative 16. Oh, I left a 0 off there. Negative 16,000. And I want V2 by itself, so I'm just going to divide by negative 20, divide by negative 20, and I get that V2 equals 800. These ones with the labels, you guys want to be extra careful. We definitely need milliliters, but we also have to say which solution we have for V2. So we're going to go back to where we were labeling. For C2 was 5%, C2 and V2 match up. So this is 5% salt solution. So for this one, just the milliliters doesn't cut it. We have to say which solution we have for each answer. So we have V2, and we also can get V1. Our first equation was that V1 plus V2 is 1600. And if I have 800 for V2, my V1 also has to equal 800 because they need to add to 1600. So 800 milliliters of my first concentration was 25%. So of 25% salt solution. A little bit longer of a label, but you need to make it that big label every time. So this one, we sometimes do get that they are the same volume, so don't be scared if you get the same thing. And those are our answers. All right. A chemist has one solution that is 10% iodine and another solution that's 50% iodine. How much of each should the chemist use to get 100 milliliters of a mixture that is 20% iodine? So I'm going to go through and I'm going to decide, okay, what's important? Karis, can you give me something important from this word problem? Okay, great. We're going to make 10% our C1. Michael, what's another important thing in this word problem? Great. We're going to make 50% our C2. Julia, what's another important thing? VF. Yep, that's once we mix them together, so that's going to be our final volume. And then we only have one number left. It's 20%, and this matches with our final volume, so it's going to be our final concentration. Now we're just going to plug everything into our system of equations. So our first equation is always just the volumes, and we don't know either of the volumes. So we're going to have V1 plus V2 equals our final volume, which is 100. Now I have to multiply together our volumes and our concentration. So our first concentration we labeled as the 10%, so we're going to have 10 V1 plus our second concentration, which was 50 V2, equals our final concentration times our final volume. We have to multiply those guys together. So 20 times 100, don't forget that step. And then I'm going to do it again by just doing substitution, because I think that one's the easiest. So if I subtract over V2, get rid of it from this side, I have that V1 equals 100 minus V2, and we're just going to plug it in right here for our V1. So 10 times 100 minus V2 is 50 V2 equals 2,000. And we just solve like normal. So we get that V2 equals 25 milliliters. Again, we have to go back up and see which concentration that matches with. It's our second one, and our second concentration was 50%. So 50% iodine solution. So we have that one of our volumes is 25 milliliters, and we know that they add to 100. So our first volume must be 75 milliliters of 10%. Iodine solution. And those are my answers.